Okay, we're next going to take a look at some sounds of English. And so again, I'm going to open my Praat program. I got rid of the picture window because we're not using it. And I'm going to open some sound files. Let me go back up to the directory where I have these. And this is the English Sounds audio. And there's 3 audio files in here. I'm going to open all of them. So we now have consonant manner contrasts, different kinds of stops, and different kinds of vowels. I'm going to start with the vowels. And so again, I've closed out all the analysis windows, and I just have the waveform window, the acoustic waveform, actual record of pressure fluctuations. A couple things to notice here. You can already see that there's some stuff and then some silence and then some more stuff and then some silence. Each one of these spikes corresponds to higher amplitude uh, oscillation and pressure. And it basically is going to be louder stuff. And when you see black spikes like this in a waveform, usually it's one vowel or one syllable. So let's see what these actually are. I'm going to, again, put the cursor here and play everything to this side of it. Looks like about 5 seconds of sound here. What are these?
E, I, A.
Okay, so that's going to be all the front vowels of English going down from high vowels to low vowels. And then over here, what is this? This looks longer.
Yeah.
So that's my extremely slow movement from E to A. So let's zoom in and get a closer look at some of these. I'm going to zoom in on these 5. And here we can see 5 clearly distinct bursts of sound. This is E, I, A, and A. So just with the waveform, we can tell some things about these sounds. We can tell roughly how loud they're going to be, and we can see that they exist. If we zoom in closer, we're going to be able to see that this is a voiced sound. Why is that? Well, because it has these evenly spaced spikes. That suggests that it's going to be a repeating wave. And if we go even closer in, so again, I'm selecting a particular time period here. This is about 100 milliseconds. And I'm going to press the SEL button to view just the part I selected. And here's the beginning of this vowel, and you can see pretty clearly here it's a repeating wave. That means it's voiced. I'm also going to zero out this selection because I want to make sure that it begins and ends at a zero crossing of zero pressure. Otherwise, my speakers are going to make clicking and popping sounds. So I'm using the key shortcuts, but if you want to do this by hand, it's in the select menu. Move start of selection to nearest zero crossing and move end of selection to nearest zero crossing. So here's what this sounds like. I'm just playing that over and over again, clicking on this bar. That's going to play the selection. And you can hear that's the beginning of an E vowel, definitely voiced, definitely repeating. So what we might want to look at more different kinds of information about vowels, though, and in particular in the handout, we saw that the spectral properties of vowels are super important. So if I want to see a spectrogram in Praat, it's going to be under the spectrum menu. And I'm just going to click show spectrogram. Oh, and now we get this second window here underneath the first one. So we still have the waveform up here. This is just pressure fluctuations. And then down here, we can see the spectrogram of this vowel. So again, this is going to sound like this.
E.
Okay, and so what do we see here? Well, the vowel starts, the spectrogram gets much darker. It's going to be white during silence, and there's going to be some different kinds of black objects during the actual sound of the vowel. And in particular, we can see this very low band of dark energy down here, and then several higher bands that are a little bit hard to distinguish up here. This is going to be the first formant of this vowel. And if I want to know what the frequency of that first formant is, I can put my cursor in it and see what the frequency says. It looks like it's about 485 hertz. or something like that. But this is a little bit imprecise. It's not clear that I found the exact center of the formant, and it's like not very precise when I'm putting my cursor down here. So you might also want to use the Praat formant tracker, and this is going to be very relevant for your homework. So on the formant menu here, show me the formants, and now we get these little lines of red dots. And what this is Praat's best attempt to figure out where the formants are in the sound. And it's not that easy to track down exactly how many formants there are and at what frequencies. And the Praat formant tracker does pretty well, but it will sometimes make errors. So it's also useful to practice looking at the spectrogram and seeing if you can see the formants and whether the Praat formant tracker is doing sensible things. So it definitely found this low one down here. That means something's going right. It looks like there's a second formant, a third formant, and a fourth formant up here. It's a little bit hard to tell by just eyeing the spectrogram. I'm going to turn the formants off for a second. How many distinct formants there are up here, but if the Praat formant tracker says that there's 3 more up here, I'm probably going to trust that. If I want to change the view settings to try to see the individual formants better, one thing you can mess with in the spectrogram is just the overall darkness, and this is quite useful. So if you go into this window, you'll see spectrogram settings, and this is the standard settings for a spectrogram in Praat. This is just how many, which frequencies can you see. So I've set an upper limit of 5,000 hertz, and that's because nothing in speech that's really relevant to perception happens higher than 5,000 hertz. The dynamic range here is going to control the darkness. I'm sorry, I'm probably off out of the window. The darkness of the spectrogram. So right now it's set to 70. And if I lower that to some lower number, it's going to make the spectrogram lighter. So let's just try 50. And if you want to see what it looks like without exiting the window, you can press apply. There you go. It just lightened up my spectrogram. That actually doesn't help that much with identifying these higher formants, but it is a useful thing to have in general, just to lighten or darken the spectrogram display. If I want it really light, I can do 30. Yeah, now you can see pretty clearly at least 2 and probably 3 formants up here. If I want it really dark, I can put it up to high numbers. And it's sort of just your personal preferences and what you happen to be looking for in the window at the time. So I'm going to set this to an intermediate value of like 50, and we'll see how that works. I'm going to turn on the Praat formant tracker. It's doing a pretty good job with these formants. As the sound gets quieter and sort of glottalizes at the end here, the formant tracker gets a little bit wonky, and that is a typical thing that happens when you get this kind of glottalization at the ends of phrases in English. Here's what the glottalization sounds like. So you can hear there's this sort of creakiness to that part of the vowel, and that's going to give trouble to the formant tracker. So we probably want to keep the formant, when we're measuring formants, we probably want to do it sometime during the modal part of the vowel, where modal means not glottalized. This is just normal voicing. In the waveform, I'm going to zoom in here for a second. You can tell that it's a voice sound because this wave is repeating. In the spectrogram, you can tell that it's a voice sound because it has these vertical striations. 1, 2, 3, 4, 5. This is what voiced sounds look like in a spectrogram. So we can look at these formants. We can ask Praat to retrieve the formants. So I put my cursor at some specific point in the vowel. I can ask it to get me the first formant, the second, the third. We're not going to be too concerned with bandwidth in here. We want the frequencies really. So that's get first, get second, get third. Or I can ask it to just give me all the formants it can find. Here's formant listing. And now this Praat info window pops up, and it's going to tell me the time at which I put the cursor. And at that time, the value for F1 is about 280 hertz. F2 is about 2,500 hertz. F3 is about 3,100, and so on and so forth. So this is a good way to retrieve format values. I'm going to zoom out and take a look at some of the other vowels here. So here's, So I'm just moving the cursor back and forth here to try to get a couple vowels in the screen with their spectrograms. Um, and so what do we see here? Well, we're getting formants tracked in these other vowels as well. And we're going to be particularly interested here in the F1 values. So actually, let me go out to see if I can get all 5 vowels. Yeah, there we go. So here's the 5 vowels.
E, I, A, A.
And what we're expecting is that these are going from high to mid to low. And so what we're interested in is seeing whether the F1 tracks that. And we can do that by separately measuring each of these. And I'm going to try to go to a point in the modal part of the vowel close to the beginning and say, get me a first formant value here. So it looks like it's about 280 for E. Here's I. About 450. That's a big jump. Here's A. 480, so going up. Here's 570, so still going up. And here's A. Oops, I pressed the wrong button. That's giving me a bandwidth. Here's 715. So the vowels are going from high to low. F1 is going from low to high. It's in an inverse relationship. Let's check out that yeah, the really slow one. You can see this is a much longer sound.
Yeah.
And what's going on here? Well, we're seeing 2 things really. This first formant is gliding upwards, and that corresponds to what we just saw in the previous 5 vowels. Also, the second formant here and the third formant to some extent are both diving. As we do this, there's a reason for that. And it's because if you look at the IPA vowel quadrilateral, you'll see that the front part of the vowel space is diagonal, where E, the highest front vowel, is also further front than the lower front vowels. That's why it's a diagonal slope on that left side of the IPA chart. And that's because for front vowels, the high ones are inherently fronter than the lower ones. There are good physical reasons why that works that way that have to do with the shape of your vocal tract and harmonics. It's pretty complicated, but there is a good physical explanation for that. So what you're seeing here is that yes, E is a lower vowel than A, and you can tell this because the F1 is going up, but also that E is a fronter vowel than A, and that's going to be reflected in the F2 over here. Examples of the Praat formant tracker sort of messing up and behaving badly. These isolated little red dots that are really probably not even part of the vowel itself. This is the Praat formant tracker guessing at a formant and sort of getting some random noise instead. These little dots up here probably also just erroneous. We're usually not going to be measuring anything up here, but it also looks like in this region, like some of the formants are getting mixed up and switching back and forth. And if I want to try to improve my formant tracker, maybe because I'm writing down formant values for my homework, I can mess around with the formant settings. So let's take a quick zoom in here. And so it looks like we're having some formant troubles in this general vicinity. What can I change in order to try to change this? Well, let's go in the formant settings. I can tell it to search for higher formants or not to search for such high formants. So like maybe I only want formants up to 4,000 hertz. I'm sorry, I'm off the screen again probably. Yeah, so what if we tried just up to 4,000 hertz? Does that help? A little bit, maybe. I'm going to reset that. That's not the first place I'd go. One of the most useful things is to just change the number of formants that it's looking for. So the default is to look for 5 formants. Usually we're only interested in 3 or 4 of them, and we just want those first maybe 3 to be as accurate as possible. what's going on here, it looks like maybe the program is searching for more formants than there actually are in the spectrogram. So maybe if we just tell it to look for fewer formants, maybe that will help. A little bit. You could even do it more radically, but this is probably going to be not so good with 3 formants. Well, it actually looks like it mostly got those first 3. That's not terrible. So you can mess with this. You can also tell it to look for more formants if you think it's missing one. So now I'm going to look for 6. And that's a total disaster with this spectrogram because there is just not 6 formants here. So you're seeing all of this just random guesses and fluctuations. There's a ghost formant here, which is probably not actually the third formant because we're looking for too many. So here's the default again is 5. And those are the main things I would mess with if I'm having trouble tracking formants in Praat. Let's take a look at the rest of these vowels. What are these about? I'm going to again scroll over here. I zoomed out and I'm going to scroll over. Here's the next 6 sounds. What are these? Let's see. I'm going to play this by clicking in here.
Ah, aw, o, oo.
Okay, so it looks like these are the back vowels, and they're going from low to high, right?
Ah, aw, o, oo.
So based on what we just saw at the front vowels, we would expect if this is a low vowel, it should have a high F1 down here. And if this is a high vowel, it should have a lower F1. And that does seem to be what we're seeing. So this is at roughly 800 hertz for F1. This one's at roughly 335. I mean, that's very rough. I can, again, get more precise measurements using the formant menu, get first formant, 324, get first formant, 780. Right? So we're seeing F1 goes down as vowels get higher. One thing to notice between the 2 series here, when we were looking over here at some of these front vowels, they typically have, these are the least front vowels because of that diagonal I told you about. But if we look at the second formant in here, this is going to be for, I think, eh. Let me make sure.
Eh.
Yeah. Here's what we get. About 1800 hertz, 1700 hertz. If we look at the F2 for some of these back vowels, you can already see in the spectrogram the second formants here are much, much lower. So, excuse me, for instance, for this ah vowel, what's the second formant here? It was about 1750 for the front one. It's about 1200 for the back one. And so this is going to be the main difference between front and back vowels, much lower F2 for back vowels than for front vowels. And then let's take a look over here. There's another one of these long glide thingies. What is this?
Ow.
So that is a very slow ow or ow. And that's going to be going from, again, from low to high within the back vowels. And so you can see F2 here is lowering a little bit, but mostly pretty steady. F1 is really diving as we go from low vowels to high vowels. And there's some funny click at the end here. That's probably me smacking my lips or something. What is that? Oh no, that's me pronouncing a very distinct off-glide wah at the end of this. That's probably what's going on there. Yeah, so this is a glide from, again, low to high vowels within the back part of the vowel space. I'm going to zoom out. Anything else going on here? Oh, we got a couple more. What's this?
E, oo, ew.
There we go. So that's front to back. You can zoom in here. This is E, extremely high second formant, somewhere in the 2500 hertz range. This is oo, extremely low second formant, somewhere in the 1000 hertz range. And actually, the third formant in oo is about the same as the second formant in E. Right? So radically different second formants here. First formant should be roughly the same, maybe not exactly the same, but pretty close, 330, 360, something like that. And then again, if we look at this as a single glide from one to the other,
Ew.
Oh, this is interesting. My telephone, when I was recording this, made some beeps at the end here. That's what these things are. You can see they look very different than human speech. This is my telephone. Here's what it sounds like if you can hear this. Yeah, so ignore that. Here's the actual vowels. And you can see here F1 is remaining reasonably steady throughout this EU sequence, but F2 is diving. Right? And F3 is coming down a fair bit as well. And that's not an accident. So F3 generally lowers with backer and rounder vowels in general. Right? Okay, so this is how to look at formants and vowels in Praat. Again, if I don't like what the formant tracker is showing me, I can mess with the settings and try to get more accurate or different kinds of readings here. Like maybe there's too many formants in this one. Well, that doesn't look any better. Maybe there's not enough formants in this one. Here's 6. That's too many formants. What about 5? Well, yeah, that looks pretty good. There's some mess up here with these scattered red dots, but usually we're not going to be measuring anything up here in the first place. And when I'm trying to decide how good the formant tracker is doing, I'm doing that with reference to what I can see without the formant tracker on. So I can definitely see a second formant here, a third formant here, and I think a fourth formant here. Whether one of these is a fifth formant, it's very hard to tell, and we almost never are interested in formants that high anyway. But you can pretty clearly see these horizontal dark lines. These are formants. This is illustrating something interesting. This looks like a fork, right? Like this formant splits into two. What's actually happening here is that the second formant is diving, and the third formant is getting so low that it's at the same frequency as our original second formant. That's exactly what we saw when we looked over here at E and OO. The second formant is all the way up here in E, and it's at almost the same frequency as the third formant in OO. Right, so they're sort of almost replacing each other or adding an extra formant in here. And so as F2 lowers, vowels get backer. As vowels are backer, F2 lowers. That's the main message here. Okay, let's take a look at some consonant manner contrasts here. So what do we have in this file? Here's what it sounds like, 8 seconds.
Ata, ada, asa, aza, ana, Allah, ara, aya.
Okay, so this is going all the way up the consonant manner scale from the most consonant-like consonants, or the least vowel-like consonants, the stops at this edge, to the most vowel-like or least consonant-like consonants, the glides at this edge. And we're going up on a continuum, so voiceless stop, voiceless fricative, voiced fricative, and then I think I did nasal, lateral, and a glide. So what can you see here? Well, again, we've got a little spike in the waveform every time there's a new word. In some of these earlier ones, you can see 2 little spikes, and this corresponds to the unstressed syllable, stressed syllable. Let's zoom in on some of these. It won't show you a spectrogram for more than 10 seconds of sound because it's just too computationally intensive to make a spectrogram over such a large stretch of time. So let's zoom in. I'm going to select the first 2 words here.
Ata, ada.
And let's see what these look like. So these are all in a position before a stressed vowel. And this is a voiceless stop and a voice stop. There's this thing in the middle. That is probably me smacking my lips as I start the second word.
Ada.
Yeah, you can hear that. So that's not actually like a real part of my speech with real in air quotes or something. What we're seeing here is a very short vowel for each one of these. So this one's tiny. That's a schwa. Here's another schwa. This one looks glottalized. You can hear the creak or the glottalization in that one. But these are little short vowels, and then the stressed vowels are big and long, like this.
Ta. Da.
Right? Okay, and then what's going on in between them? Well, this is the consonant manner part. So here you can see almost total silence, white space, in between the first and second vowel. Here it looks like there's a little bit of sound still in between the 2 vowels. So we're going to zoom in, check out what these look like. So here is the voiceless stop. And what you can see here is we get almost total silence in this part during the stop closure. There's these little vertical spikes, and that's going to be the transient or the burst. Here's what this sounds like by itself. It sounds like a click. It doesn't sound like something that would even come out of a human vocal tract, but this is what happens when you isolate really short components of speech. It doesn't even sound like speech anymore. And you can see that this is followed, this burst, by eventually a vowel. You can tell this is a vowel because it has these vertical striations in the spectrogram and repeating peaks in the waveform. But in between the burst here and the vowel part, which starts somewhere in here, there's this whole stretch of just like black stuff, sort of random looking, or gray and black stuff in the spectrogram. And this is what frication noise looks like in a sound file. In particular, this is going to be aspiration. It's going to be glottal frication. Pretty clearly colored by the coronal stop and by the following vowel, but this is aspiration. And you can see this is pretty long. It's about 40 something milliseconds in this particular stop. So that's an aspirated stop for sure. What about the voiced one? Well, here again is this like lip clicking noise I'm making. And then here's the schwa in ada. This is the glottalized schwa. You can see the glottalization because the voicing peaks here are not even. They're all over the place. That means there's some sort of funny thing going on with my glottis. And this happens a lot at the beginnings and the endings of phrases in English. And then this dies down, and again, we have maybe near silence in here, but there's still a little bit of something going on. And if I darken the spectrogram, this will be even clearer. So I'm going to go to Spectrum, Spectrogram Settings, and change the dynamic range back to the default of 70. And now you can see there's definitely, you can almost see formants going on. You can definitely see low frequency energy. You can see a repeating waveform in here. And this is because during the stop closure, my glottis is still vibrating for this voiced stop. And what you get is what's sometimes called a voice bar. So it's just extremely quiet periodic energy voicing. And it's kind of hard to hear, but let's see what this sounds like. Yeah, so that is me very quietly maintaining voicing while my mouth is closed. Or more properly, while my tongue tip is blocking the exit from my vocal tract. And then again, just like with the voiceless one, there's going to be a burst here. So let's zoom in. You can see this like little perturbations. Those are going to be bursts. I'm going to zoom out a little bit more than that. So that's probably more than the burst. I would say this part is probably the burst. And then everything afterwards is vowel. Here's what the burst sounds like. Again, it's like a click. It doesn't even sound like a human voice. That's what transients sound like when you separate them out from the rest of a sound. So that's the difference between a voiceless and voiced stop. I'm actually going to break here because my computer is running out of batteries and I need to plug it in. Plus, it's a good point to break. The next video, we'll take a look at the other consonant manners and then also at different kinds of stops in American English.